everyone. Today we're going to be learning 6.4, day 2, and we will be continuing on the factoring of polynomials, and specifically we will be using grouping to factor. So let's go ahead and take a look at the steps of factoring again. As a reminder, these are the steps that you should take to remind yourself of what the steps that you should follow for factoring any polynomial. The first step should be looking for the GCF. So yes, always factor out the GCF. That will help you to reduce any necessary further factoring when you think you're done. Secondly, if there are some clues, if there's only two terms, then you may want to check for difference of square or cubes. There's no such thing as a sum of two squares because you will not be able to factor that. But you should have x squared, for example, minus 100, that's factorable. That's a difference of square. A sum or a difference of cubes would be like x plus 8, x cubed plus 8, or x cubed minus 125. Those would be examples of sum or difference of cubes. When it's three terms, you're just going to go through and use whatever method that you know of x factoring, factoring by square, or whatever other methods that you know, as long as you're getting it correctly. There's many different ways of factoring. However, if there's four terms specifically, you may want to try factor by grouping. And it's not guaranteed to work all the time, but at least it's worth a try. So that would be what we are going to focus on today, the group factor by grouping. So here, let's take a look at some examples. In example 1a, we have the direction says factor, and we notice right away that there are four terms here. So the way that the factor by grouping works is we're going to pretend that the first two terms are a group and the second two terms are also a group. So basically we are being separated into two separate groups here, and we're going to apply the concept of GCF to factor the common terms. So in this case, between the first two terms, I see that there's an n squared in common. So we're going to factor that out just like distributive property in the old way. We have 8n left minus 7 in the first group. And then looking at the back side, there's a plus sign in between the two parentheses, so we're going to bring that down. And looking at the second two terms, we have 7 in common. So factor that out, and we have 8n minus 7. At this moment, right away, most of you are going to realize that there's something magical happening. The parentheses look exactly the same. And that's what we want, because the whole idea of factor by grouping is so that you will create a new common term. And once again, you will use the idea of the GCF to factor out this common term. So that way, we will pull it out, 8n minus 7 in the front, and we cross it out. So what is left, remember usually that's how we put the rest in the parentheses. So what is left is that n squared and that plus 7 over here. So the complete factorization of this problem is right here. And of course, as a word of caution, you also want to just check individually to see if the terms can be factored any further. Sometimes they can be factored like a difference of square or a sum or difference of two cubes. So that would be things that you want to pay attention to when you're factoring. But in this case, we're all done. So let's take a look at this problem again. There are four terms, so right away it should trigger your mind to think, hey, can we try factor by grouping here? So in fact, we're going to go ahead and give it a try. So group the first two and group the second two. In this case, there is a difference between this problem and the last one. If you notice, the last one, the sign in between is a plus, and this one, the sign is a minus. So in order for you to get back to the original problem, which is a plus 18, you would need to change that sign to a minus sign, because when you distribute it, you got to get back to the original. So that would be a negative 15x when you distribute, and negative times negative will give you the original 18 back. If you do not change this sign, you will get a negative times positive, which is negative, which is not the original. So for that reason, we must change the sign in the middle when this middle sign is a negative. Okay, just wanted to make sure that I clarify. So now that we are grouping the terms together, we're going to go ahead and proceed with what we just practiced. Again, separating them, pretending they are two different groups. So we're going to factor the first group. There's an x squared in common, and we have 5x minus 6. And then bring down the minus sign. Between the second two groups, the two terms, we have a 3 in common. So factor that out. We have 5x minus 6. And once again, magically, these two parentheses look exactly the same. So we're going to factor out the GCF one more time. So take out 5x minus 6 from both of them. And what is left is that we have x squared minus 3. So that is the complete factorization. Once again, we double check each term. It's not factorable any further. So this would be the final answer for the factorization. Let's take a look at the next problem. Oh, here's an opportunity for you to actually try the problems. So go ahead and pause this video. And if you need some directions, you can follow question 1A that we just did in the example above. So go ahead and pause the video to try it, to see if you know how to do this without looking at the answer. Okay, hopefully you had a chance to try the problems. Once again, we are going to group it because we have 4 terms. So separating the parentheses. And again, taking a look at the first 2 terms, we are going to factor out b squared. And we have b plus 2 left. Bring down the plus sign. And even though there's nothing in between, like b and 2, nothing in common, we still want to do it as a general practice. We can just factor out a 1 because we don't want to leave out any room for error later on. If you don't see a number, then you may not put that plus 1 in the back. So for that reason, we're just going to factor out a 1. And once again, now that you see that there is a common term, we're going to factor it out using the GCF method. Pull out these 2 common factors, and what is left is that we have b squared plus 1. And that should be the correct answer. Did you get it right? Good job if you did. If not, then let's try again. Again, this is another problem that you can try on a factor by grouping. And this time, notice that you are practicing one that has a minus sign in between, so be careful. So go ahead and try the problem first. Pause the video before you check the answer. Hopefully you had a chance to try the problem. Let's go ahead and look at the answers. So we're going to group the first and the second 2, separating by the minus. And the minute that you realize that's a minus in between, once again, you need to change this sign over here to the opposite. So that way, when you distribute it, you will be able to get the original back, which is a minus 35. So for that reason, once again, you will be able to get back a minus 15v and a minus 35 when you change the sign. So don't forget to do that. And let's go ahead and separate it and do the factor by grouping method. Between the first 2, I believe that we can factor out an 8v squared, and which leaves us 3v plus 7. Bring down the minus sign. Between the second 2 terms, there is a 5 in common. So we've got 3v plus 7 once again. Yay, we got 2 parentheses that look the same. And so therefore, we're going to factor it out using the GCF. So it's 3v plus 7, the common factors. And what is left is that we have 8v squared minus 5. And once again, double checking the terms inside. We don't have anything else that we can do to factor. So that is the final factorization. Hopefully you got the problem right. And so now that we have a few problems for practice, you are ready to try more and tackle the problems on your own. Let's take a look at the next problem. So we're going to move into the word problem in this lesson, and it involves volume because we're going to apply the cubic functions into the real world situation. So here's a reminder for the formula that when you're working with 3D objects, for especially a prism in particular, the volume is given by length times width times height. So that is the formula that we're going to be using to solve the next problem. So let's take a look at the problem. Example 2 says to build a hefty wooden feeding trough for a zoo, its sides and bottom should be 2 feet thick. and its outer length should be twice its outer width and height. So based on this information, it's describing a 3D picture, and there's a picture right there. But let's go ahead and draw another illustration so that we can see more clear the dimensions. So basically, this straw is made of wooden frame. So if you can think of it like, the whole thing on the side is filled with basically made of wooden pieces. So each of the thickness of the wood is 2 feet thick. So that's a pretty big trough, the container. And so the same idea on every face, basically, it's filled with these wooden pieces. So we have 2 inches, kind of like a separation to make the actual container. So that is the ideal situation right here, the realistic illustration. So let's read the rest of the problem. It says, what should the outer dimension of the trough be if it is to hold 288 cubic feet of water? So we have volume right here. So we know, as in the previous screen, we know the volume is equal to the length times width times the height. But when we are talking about the volume, we cannot include these wooden frames here. So we got to take it out in our volume calculation. So therefore, we need to actually calculate the true length, width, and height of this container. So if based on this, it says the length, this is the length, this is the width, and this is height. It says the length should be, the outer length should be twice the width and the height. So if we let the width and height both be x, then the outer length should be 2 times x because it says it's twice. However, when we are doing the actual calculation for the volume, we need to take out these frames in the corner. So that makes the inner length is actually 2x minus 2 on each side. So that would be a minus 4. The same thing for the width here, so it would be x minus 4. But for the height, you notice that there's no top right here. So therefore, we only have the base. So we're only going to subtract 2. So it becomes x minus 2. So our new formula for the volume, we are given the volume is 288. We know the length for the inner length for the volume calculation, it should be 2x minus 4 is right there. The width is actually x minus 4. And the height is x minus 2. Remember, there's no top, so that's why it's only x minus 2. So this is the equation that we're going to use to help us find x. And based on what we have here, we need to undo the entire right-hand side because when we don't have equal to 0, we cannot solve this, right? So therefore, we need to undo the right-hand side. And this is when we need to make use of our multiplication skills. So all those foiling, superfoiling skills will come into handy now. So we're going to first, I think it's easier to just multiply these two. So we're going to FOIL that. So we got x squared minus 2 minus 4, that gives us minus 6x, and then a plus 8. And then we're going to bring down the 2x minus 4 here equals 288. Next, we're going to need to use superfoil to multiply the next two parentheses. So we got 2x squared, and I'm going to put it up down here, 2x cubed. Multiplying the next term, we got a minus 12x squared, and then a plus 16x. Next, we're going to multiply the second term, so it's a minus 4x squared plus 24x, and then a minus 32. We're going to combine the like terms, so we'll have 2x cubed minus 16x squared plus 40x minus 32. And that is what we get on the right-hand side when we superfoil. Next, we're going to bring down the left-hand side, which is 288. And we're going to actually want to zero out the left-hand side. So we're going to minus 288 to both sides. And then combining everything, we're going to have 2x cubed minus 16x squared plus 40x minus 320. Well, supposedly we're going to factor out what's on the right-hand side. But before we do that, there's one little thing that we could do. Notice that every term is even, right? So there's a 2 in there. There's a factor of 2. So what I'm trying to do is make this problem a little simpler by dividing everything by 2. So that makes still the left side 0, and then the 2's will be gone. So we have x cubed minus 8x squared plus 20x, and then minus 160. So the problem is a little bit less now. So now we're going to apply what we learned today, which is 4 terms, right? Factor by grouping. So we're going to group the first 2 and group the last 2, and we're going to factor it just like we did earlier. So factoring out the common terms, that will be x squared, and then we have x minus 8. Here, bring down the plus sign, and we have a 20 in common. So we have x minus 8. And yes, again, we have the same common term in the parentheses. So we're going to pull it out again, x minus 8. And then what is left over is x squared plus 20. So if you actually look at, let's bring down the zeros. If you actually look at the rest of this, this is not factorable, definitely. So the only real 0 is going to come out from here, the first factor, because the second one is going to give us imaginary solutions. So the only solution is taking this, set it equal to 0. We have x is equal to 8. So we found the dimension x is equal to 8 feet for this problem. And let's go back and evaluate the problem. So going back to this situation, we now know that the dimension for the outer volume is 8 because x is equal to 8. The width is also 8. The circled one is the original. Remember the outer extension, the outer dimensions. So that would be 8, 8, and that would make it 16. So the answer to this problem, the dimensions are length, width, height. So the length is 16, the width by feet, and then the 8 feet is the width, and then 8 feet is the height. And that is the answer to our problem. And let's double check. The problem says what should be the outer dimension. So that would be the answer, 16 by 8 by 8. And please go ahead and at this time watch the second video, part 2, to finish the lesson for today, which is about this word problem right here. Have a nice day. See you later.